In this video, we're going to study how to integrate 1 over square root 1 plus x squared. For a problem like that, we normally use the x equal tan theta substitution. So let's see what other options are out there. So as the first method, we're gonna recall one identity. For example, if you look at the derivative, if you look at the derivative of the hyperbolic sine function, so sin inverse x, and you know that it is 1 over x squared square root. So that is exactly what we have. So that means because of that, then you can say that the integral of 1 plus x squared is dx is equals to sin uh, inverse x plus c. Now we're going to use one of the identities. So we know that sin inverse x is equals to natural log x plus 1 plus x squared square root plus c. And then this is true for any x. So x is any real number. Because you can see that this term is always positive. So this term is always positive. So we don't need the absolute sign here. Okay, so that is how you integrate using the identifying the integrand as the derivative of sin inverse x. So let's look at the second method. So as a second method, we're going to use a substitution. We're going to use a hyperbolic function substitution. So the method 2, what we're going to do, we're going to use x equal sin theta. So if we say x equals sin theta, and then what we can do is we can take the derivative, and we know that the derivative of so it's dx equal derivative of sin is cos theta d theta. And then we also know that one of the identity, so cos square theta minus sin square theta equals to 1, and this says that cos square theta equals to 1 plus sin square theta. So that we can use. So and because of that, then we can say that 1 over 1 plus x squared square root dx is equals to 1 over 1 plus sin square theta square root, and then dx is equal to cos theta d theta. And because of the hyperbolic sign identity, and you can see that 1 plus sin square theta is simply cos square theta. So once you take the square root, so this is cos squared theta square root, and then this is cos theta d theta, and you can see they can cancel out. So they can cancel out, and then you just get d theta. So that means this is simply theta plus c. So that's the most interesting one. So that means theta is taking the inverse. You can write this one as sin inverse x plus c. Again, using the identity, we can write this one as ln x plus 1 plus x squared square root. So this is pretty much the last thing that we did in method 1. Okay, so this is how you use, and again this is true for all x, and this is how you use the hyperbolic sign substitution to do the problem. So as the next method, let's look at the traditional way to do this problem. So what we normally do is we're going to say x equal tan theta, x equal tan theta. So take the derivative, so dx equal secant squared theta d theta. And then also we can use the identity, so we can say that secant squared theta equal 1 plus tan squared theta identity. So that means so what will happen, so this is 1 plus x squared square root dx, so we can substitute, so we can see that this is 1 plus tan square theta square root, and then dx is simply secant square theta d theta. And you can see that the because of the identity, the bottom simply become 1 plus tan squared, means secant square theta. Once you take the square root, this can be secant theta, and then we have secant square theta d theta, so we'll cancel out one of them, so it's going to cancel out one, so that means we're going to get secant theta d theta. And we know the integral of secant, which is natural log secant theta plus tan theta plus c. Now only thing that we need to find is, because we know that so tan theta is just x, but we need to find the secant. To find the secant, what we can do is we can use the identity, because that will be the easiest for this problem, because we know that the secant theta is 1 plus tan squared theta square root. So that means if we plug in for that, you can see it is 1 plus x squared square root. So that means we can plug in all of them here. So this is ln tan. I'm going to write the tan first, so it's a tan, so which is x, and then secant is 1 plus x squared square root. Again, now the problem is, like you can see, this is always positive, so you do not need the absolute sign, so we write it without the absolute sign, because this is one step closer, because absolute sign is another function, so we don't need that. Okay, so this is true for all x in real. So that is the standard way to do this problem. And also to find the secant, we can also use the triangle method if you like. So that means we can use x equal tan theta to draw the triangle. So that is like another way to get this answer. So that means if you call this is theta, because tan theta equal x, so x you can write as x over 1. So that means this can say x over 1, because opposite of hypotenuse, opposite of adjacent. Now using the Pythagorean identity, this side is simply 1 plus x squared square root, and you can see that the secant theta according to this is 1 plus x squared square root. So that's another way to get this term. Okay, so that's the third method. So let's go to the fourth method. As the fourth method, we can use one of the Euler's substitution. So we can substitute 1 plus x squared square root as x plus t. X plus t. So t is the parameter. So the new variable. So once you do that, now what we can do is we can square both sides. Once you square both sides, and you can see that, so you're going to get 1 plus x squared on this side. The other side you get x squared. So the x plus t squared, so which is equal to x squared plus 2xt plus t squared, and you can see that x squared get cancelled. Actually, that's the whole point here. That term get cancelled and you get a new substitution without the x squared term. So this says that if you solve for x, and you can see that you're going to get x equal 1 minus t squared divided by 2t. That's what you get. And then also you can split this as write as two fractions. So if you write 1 over 2t, so that's the first term, minus if you divide the second term, you get t over 2. This is useful when you take the derivative. Now we take the derivative to find the differential. So when you take the derivative, you can say dx is equals to 1/2 from the first term, and from the second term, no. So you get negative 1 over 2t squared from the first term. From the second term you get 1/2. So times dt you can write this in a different form. You can pull out the 1/2, and then once you pull out 1/2, you have 1 over t squared plus 1 dt. So this is also equals to negative 1/2 1 plus t squared 2t squared 1 plus t squared or t squared dt. So this will be useful when we do the simplification. Okay, now we have everything we need. Actually, we also need to find one more term. Now what we're gonna do is, since we know what is x in terms of t, we're gonna simplify x plus t term, because x plus t is the actual term we're gonna use. So we're gonna simplify that. So we can say 1 plus x squared square root according to substitution, which is equal to x plus t. And if you substitute for x, so you can see that 1 over 2t minus t over 2 plus t. So these two get simplified. You can simplify these two. So that means you're gonna get 1 over 2t plus t over 2. So again, you can simplify this also. If you pull out 1/2, you can see that this is 1 over t plus t. And then this is going to be 1/2 1 plus t squared over t. That's what you get. Now we can substitute all these into the integral and see what's going to happen. So let's do that next. And now we're going to substitute all these into the integral. So it is 1 over 1 plus x squared square root dx. So the first thing is we can write the integral as x plus t dx. Now we're going to substitute for all these. So first we can write, we know that x plus t is equals to 1 over 1 plus t squared 2t, and then dx is a negative 1/2. We can write it outside 1 plus t squared over t squared dt. And you can see the many terms get cancelled now. So we're going to cancel these two, and also one of the t get cancelled, and then also 1/2 get 2 and 2 get cancelled. So that means you only get negative 1 over t dt. So that means this is easy to integrate. So this is simply negative ln absolute of t plus c, and then we can substitute for t now. So from the substitution, and you can see that simply this is simply negative ln 1 plus x squared minus x plus c. This is a substitution for t, because we know that 1 plus x squared square root was equal to x plus t. So according to this one, t is 1 plus x squared minus x. So that's where it's coming from. So this is that 1 plus x squared minus x, which is equal to t. Okay, and then also notice that, so we can say since 1 plus x squared minus x is equals to 1 over 1 plus x squared square root plus x. From the difference of squares, we can write it like that, because when you multiply the two, you get 1. So because of that, it's 1 over, then we can bring the negative sign in and flip over, and then you can write the final answer like this. So that means because of that, then we can write it like this. So dx. So because the negative sign we can flip over, so we can write this one as ln. Now with the positive value, so we don't need the absolute sign because it's always positive. So we can write this one as using the same format we used earlier, x plus 1 plus x squared square root plus c. So this is true for all x. So this is like little lengthy because of all the steps that we need to do. Okay, let's look at how to avoid some of these calculations. What we're going to do, we're going to use the other option for the Euler transform or Euler substitution. So in this one, what we're gonna do, so we're gonna say 1 plus x squared square root is equals to minus x plus t, or t minus x, because this comes like much faster. So let's see all the steps as before. So we're gonna square. So once you square, you're gonna get 1 plus x squared. On the other side, you're gonna get t squared minus 2xt plus x squared, and you can see x squared term get cancelled. And then now you can solve for x again as before. So we get x equal t squared minus 1 over 2t, and then we can also split it and write it this one as t over 2 minus 1 over 2t, and then we can take the derivative and write it like this. So you can take the derivative. So once you take the derivative, dx equal 1/2, and then what will happen here, because it's 1 over t, that is means t to the negative 1. So when you take the derivative, it's going to be plus now, 1 over 2t squared times a dt. And then you can see that this again, we can pull the 1/2 out and use the common denominator t squared. So you can write this one as t squared plus 1 over t squared dt. Now this time we don't have negative sign, it's positive now. And the only thing that we have left is we need to solve, simplify for 1 plus x squared, the integral. So this is t minus x, and if you substitute, so t minus x means t over 2 minus 1 over 2t, and then you can see that this simplifies to t over 2 plus 1 over 2t. That means this is simply 1/2 times again t squared plus 1 over t. So as before, we're going to substitute all this into the integral. So let's see what we get. So we have integral 1 over 1 plus x squared square root dx. So first we can write 1 over t minus x, and then we have dx. So let's substitute. So we already simplify 1 over t minus x. So, and then it's also upside down. So that means we can write this one as 2t over t squared plus 1. We simplified that earlier, and then dx. And the dx is also equals to t squared plus 1 over t squared dt, and also we can leave the 1/2 outside of the integral. And you can see that there are a lot of cancellations again. So we're going to cancel this. We're going to cancel one of the t's, and also you can cancel 2 with 2. So we finally end up getting 1 over t, integral of 1 over t dt. So this is much simpler. And then this is just the ln natural log t plus c, and then again using the substitution. So we know that 1 plus x squared square root equals to t minus x. If you solve for t, you can see that you simply get ln, we can write this as x plus 1 plus x squared square root. So we directly get the answer. So this is quicker than the previous one. Also, we don't need the absolute sign, so we can write this one as without the absolute sign, because this is considered the final answer. Because with absolute sign we have one step, so you have to check whether you need the absolute or not. Okay, so this is true for all real numbers. Okay, so let's look at what is the last option. So as the next option, what we're gonna do is so I'm not gonna call it like a 6, so I'm gonna call it 5.5, because this is not really like a complete argument. So what happened, let's say by mistake we try to use the integration by parts. So we try to use integration by parts. So let's look at the problem. So what we have is 1 over 1 plus x squared square root dx. So what we can do, we're gonna exaggerate, we're gonna pull out 1 and then write 1 plus 1 over 1 plus square root 1 plus x squared dx, and then we're gonna pick this part as the dv and this part as u. We normally don't do that, but let's see what will happen if you do that. So you can see, so u equal 1, dv equal 1 over 1 plus x squared square root dx. Yeah, so it's, I mean, so like this is really not a good way to do this. So you can see if it has a derivative, this is gonna be du equals 0, and then dv, so it's kind of like we are using the same thing again. And if you recall from the derivative, so that's why I'm not going to call it this is a method, because this is simply sine inverse x. I have seen this kind of things like in student answers, like they forgot the problem and try to kind of work around, but you can see you are actually doing the problem again, because that's exactly the integral. But let's say you forget that, and then what will happen, now you're going to plug into the integral. So this integral is so it is u dv, so this is the integral u dv, so this is uv minus v du, and if you plug in, you can see that you're going to get sin inverse x minus, what will happen here is, it is v times du is 0. That means this term goes away. So that means, so you simply get sin inverse x. So that means it's really hard to make a mistake. So you will get back to the and then again use the identity. So we can write this one as ln x plus. I'm not going to call this is the actual method, because this is because what we are doing here is, you can see we actually have already integrated the problem. So, and then why we gonna do that? Okay, but this is just for like education purpose, just to see like what happens sometimes. So this is not really a technique, because we have already used the result that we need to prove. Okay, so these are the ways to integrate 1 over 1 plus x squared. So we discussed 5 different methods. So see whether you know like some other techniques as well, other than these methods. Thank you.